Welcome back. Today we're going to start our discussion on the atomic nature of matter. We're going to start about 2,500 years ago with a Greek philosopher named Empedocles. Now, Empedocles did not believe in the atomic nature of matter. He believed that matter was actually made up of either one or a combination of four elements. Perhaps you've heard of these four elements: earth, water, fire, and air. And Empedocles was able to use simple things surrounding us to describe his belief. For instance, let's take a tree. Empedocles was able to prove, in his mind, that a tree consisted of all four of these elements. Of course, a tree comes from earth, doesn't it? When a tree dies and falls down, doesn't it decay over the period of several years and returns to earth? Doesn't a tree have lots of water in it? If you cut into a tree, don't you find lots of sap? The fruit that a tree bears is full of water. Trees are made out of the element water. You can start adding a tree to an existing fire, and doesn't the fire get bigger? There must have been the element fire inside of that tree to create more fire. And as that tree burns in the fire, doesn't it generate lots and lots of gases or air? So a tree is made out of all four elements. A rock, on the other hand, would only be made out of probably one element, earth. What do you think something like a bunny rabbit would be made from? What elements in Empedocles, in the Empedoclean theory, would a bunny rabbit be made from? Yeah, if you said all four, similar to our thinking of a tree, you would be correct. Now, it wasn't until the mid-1800s a guy named John Dalton came on the scene. And he was actually able to use the experimental work done by other individuals to prove the atomic nature of matter. So he is the individual that discovered the atom. He ended up not using his own experiments, but he was able to use the experimental work of others to prove the existence of an atom. He thought that an atom was indivisible. You couldn't get smaller than an atom of a particular element. So, for instance, if I had a sample of gold and cut that sample in half, and took one half and cut it in half, and took one half of the remaining half and cut it in half, and continued that thousands and millions of times, I would eventually get to a particle that could not be cut in half any longer. Once you got there, in Dalton's mind, this was an atom. It was made out of indivisible particles. And every atom, or every element, had its own characteristic atom. They had different masses and different sizes. This atom became, or this model of the atom became known as the billiard ball model of the atom. Sort of like a pool ball. He would envision an atom being made up, or an element being made out of numerous particles similar to a billiard ball or a pool ball. And once you got to that billiard ball size sphere, you could not break it down any smaller than what it was. It was an indivisible particle. Now, in the late 1800s, a guy named JJ Thomson came on the scene. And he did some work with something called a cathode ray tube. Now, I have another video demonstration for you of how JJ Thomson used the cathode ray tube to discover something. He discovered something smaller than an atom. He is credited with the discovery of a subatomic particle called an electron, which is abbreviated with a small letter E and a negative sign after it. He found that this particle was 1/1837th the size of a hydrogen atom. Now you might ask yourself, well, what's so profound about something that's smaller than a hydrogen atom? Well, you should know that a hydrogen atom is the smallest of all atoms. So if you found something smaller than a hydrogen atom, didn't you now discover a subatomic particle? And that an atom is not indivisible. An atom is made up of even smaller parts. So John Dalton's model of the atom was not completely correct. The atom did exist, but it was composed of smaller subatomic particles. John Dalton discovered the first, and it was an electron, and he used a cathode ray to prove the existence of subatomic particles. Now, Thompson, as soon as he discovered the existence of an electron, he also thought to himself that there must be a positively charged particle that existed. He found that these positively charged particles will have the same amount of charge as an electron has, however, an opposite sign. These particles are called protons, and they are abbreviated with the lowercase p and a positive sign. He figured out the mass of these particles to be almost the same size as a hydrogen atom. They're about 1,836 times bigger than an electron. So once again, almost the same size as a hydrogen atom, but just a little bit smaller. Think about how much smaller. If they're 1,836 times bigger than an electron, and an electron is 1,837 times smaller than a hydrogen atom, in Thompson's mind, a hydrogen atom consisted of a proton and an electron. The sum of those two masses would be the size of a hydrogen atom. So, atoms in Thompson's mind were composed of these protons and these electrons combined within a sphere. So, he envisioned the fluorine atom to look something like this. A fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8, 9 positive charges, so 9 protons. And it also has 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. The electrons were embedded in Thompson's mind in a positive matrix of these protons. JJ Thomson was English, and they have a dessert in England called plum pudding. To us, it looks like a cake. And the plums, to us, we would maybe envision as raisins. So if you can imagine a cake with raisins embedded in that cake, that would be a British dessert called plum pudding. Well, think about this plum pudding compared to Thompson's model of the atom. They have similarities. So the Thompson model became known as the plum pudding model of the atom because people could envision Thompson's model by metaphorically envisioning a piece of plum pudding cake. So this became widely known as the plum pudding model of the atom. The cake portion was that positive matrix of protons, and the raisins or plums embedded within the cake were the electrons that Thompson discovered. Okay? So we've gone from Empedocles and 4 elements, earth, water, air, and fire, to John Dalton and an indivisible particle that he was able to discover called the atom, to the Thompson model of the atom that consists of protons and electrons. I think that's good enough for today. We'll carry on with our discussion next time. See you soon. Bye-bye.